Hey there, Seahawks. It's Miss Adams, and in this video, we're going to take a look at the basic theoretical probability. All right, so an introduction to probability. A lot of this will seem pretty familiar, and then as we get into the next, this unit and the next unit, some of the things will be a little bit new and a little bit more complicated. But the basics. Probability is a number that represents how likely an event is to happen. Probabilities range from 0% to 100%, or 0 to 1. A probability of 0% indicates that the outcome is impossible. A probability of 100% indicates that the outcome must occur. Probabilities are usually expressed as a ratio or a percent. A ratio is just a fancy word for a fraction, but can be expressed as a decimal. All right, usually percents make a lot more sense to us than fractions as far as giving us like an idea of what that number means. But fractions are quick and easy and more accurate when you're looking for like the actual answer. All right, so this is kind of something that I use to help me remember how to go from a decimal to a percent or a percent to a decimal. So if I'm going from a decimal to a percent, I'm going to move my decimal place 2 places to the right. That's why the 2 is in the middle. And if I'm going from a percent to a decimal, I'm going backwards. I'm going to move my decimal place 2 places backwards. So when it's a percent, my decimal is really in the back. It's after my numbers. And if I move it 2 places back, it'll change it into a decimal. All right. So theoretical probability and experimental probability. Theoretical probability is what we're going to focus on for a little while. Is a calculated probability based on the possible outcomes when each outcome has the same chance of occurring. This is what we expect to happen. Experimental probability is a probability based on data collected in experiments. This is what actually happened when we try it out. Okay, so the formula for calculating the probability, no matter if it's theoretical or experimental, it's the same thing. The probability of that event occurring is the number of desired or successful outcomes divided by the number of possible outcomes. Okay, so side note, P of stuff in parentheses is read as the probability of, and then you say the stuff that's in the parentheses. All right, so flipping a coin is a pretty basic concept when it comes to probability. So what is the probability of getting a heads when you flip a fair coin? All right, so a fair coin, it's not weighted. It's not any more likely to pop up heads or tails. Okay, so with a fair coin, we have 2 outcomes. Our outcomes are heads or tails. All right, so what's the probability of getting heads? Well, that's 1 out of the 2 possible outcomes that I have. So 1/2 or 0.5 or 50%. Okay. Rolling a dice. So I'm rolling a die, a single die. We're assuming it's a fair die. It's not loaded or weighted or anything like that. What is the probability of rolling a 3? Okay, so with a die, there's 6 sides. All right, so my options are 1, 2, 3, 4, 5, or 6. The probability of rolling a 3 is 1 out of 6 outcomes. Okay, so 3 is what I'm looking for. I have 1 of those out of 6 total outcomes. So this is 16.7% about. But you could just leave it as 1/6. What is the probability of rolling a 2 or a 6? So when I roll my dice, I could either roll a 2 or roll a 6. All right, well, I have 1 2 and I have 1 6. So I have 2 outcomes that are a success out of 6 total possible outcomes, which simplifies to 1 out of 3. If I want that as a percentage, I do 1 divided by 3, multiply by 100, or just move the decimal 2 places. That gives me 33.3 repeating percent. What is the probability of rolling a 5 and a 6? Well, if I'm only rolling a single die, this can't happen at the same time. I can't get a 5 and a 6 at the same time if I'm rolling a single die. So the probability of that happening is 0%. All right, marbles in a bag. What is the probability of picking a yellow marble from a bag with 3 yellows, 2 red, 2 green, and 1 blue marble? All right, so I have 3 yellows, 2 red, 2 green, and 1 blue marble in my bag. I want to know the probability of picking a yellow. So the probability of yellow, that's the notation there. Well, I have 3 successes. So I have 3 yellows out of a total of 8 possible outcomes. 3 plus 2 plus 2 plus 1 gives me the 8. And if I could leave it like that, that could be my answer, 3/8. Or I can change it to a decimal or percentage, which is 37.5%. All right, we have a bag with 9 red marbles, 5 blue marbles, and 3 green marbles in it. What is the probability of selecting a non-blue marble? All right, so this one, the probability of a non-blue marble. This time I'm going to do it without drawing it out. But if you need to draw it out, you can still do that, okay? So I want a non-blue marble. So in order to be a success, it has to be a color that's not blue. All right, so my success is, I have 9 red, that's not blue. I have 5 blue, well, I'm not going to put that as a success. And I have 3 green. So 3 green, those are not blue. So those are my successes out of my total possible outcomes. I had 9 red, 5 blue, and 3 green. So 9 plus 3 gives me 12. 9 plus 5 plus 3 gives me 17. And this works out to be 70.6%. All right, go Seahawks.